this how-to video, we're going to show you how to do the most common tests you might do with the TPI-1001. And those are testing bandpass, low-pass, and high-pass filters, testing antenna resonance, testing amplifier gain and characterizing them, testing cable loss in coaxial cables, and immunity tests. First is how to test bandpass, low-pass, and high-pass filters, and you can characterize other types of frequency domain filters as well. In this test of a bandpass filter, we're simply going to connect it using cables between the RF output and the RF detector input. In many of the tests we're going to perform with the signal generator, you're going to first connect your cables that you're going to connect to your device under test directly to the output, through a barrel, and into the RF detector input. The idea is that we're going to subtract out the characteristics of our connecting cables from the actual device under test's final plot. To do this, we first set the frequency range of the test we're going to perform by putting in a start frequency and then putting in a stop frequency. When you do this, the center frequency will be automatically calculated. We go ahead and hit the start button and do a scan of the cable assembly itself. Then we hit store to put it into temporary memory. And before we do our test of our actual filter, we select relative mode. We then insert our filter into the cable assembly. We know this filter operates around 400 MHz, so we've set our frequencies appropriately. We then hit the start button and we get a nice plot of the filter's characteristics. Remember, you can move your cursor along the plot's line and see the relative dB loss at different exact frequencies. Next is testing antennas, where we'll need a directional coupler to perform the test. A directional coupler allows us to sample a small amount of RF coupled off the line between its input and output connectors. A 3-port coupler has an internal termination instead of a 4th port, and we are looking at the energy absorbed by the antenna, so we connect it to the coupler's input, not output, and we connect our RF output from the signal generator to the output of the directional coupler. And here's how it's hooked up on the bench. For the first scan, we're going to need the input of the directional coupler shorted or not connected to anything. We're going to do a scan of the cable assembly and directional coupler to subtract its characteristics from our final antenna plot. Now we're going to scan our directional coupler and cable assembly in the reflected mode, and then we're going to go ahead and store it and go into relative mode. And now we go ahead and attach the antenna to the in port on the directional coupler. We go ahead and do our antenna scan. And once you've done your scan, you can go ahead and select between return loss or VSWR or relative mode without rescanning. Then use your cursor to look along the line and find the exact values at different frequencies. I'd like to show you a few plots here where we have rich numerical information displayed on the screen by the analyzer, and we can set that up in the analyzer's markers area. I'll show you how to do it. Here's an analyzer plot from an MMIC amplifier. You go to the Markers and Grid drop-down menu, and there you can choose the valley, the low spot. You can choose +3 and +6 dB points, and it will display the information numerically, or the full range of the scan. You can also select the opposite of those, the peak reading, -3 and -6 dB, and of course the full range again. You can also go ahead and change the colors of the scan itself, or the numerical information, and the size of the text. The color of the grid, the resolution, and background color are controllable also from this drop-down menu. Next is testing RF amplifiers. The hookup is straightforward, going between the RF output and the RF detector in. If you don't know the gain of the RF amplifier, it's always good to put an attenuator in it first, so that we certainly do not exceed the +10 dBm maximum input level of the RF detector input. Even better, go without the attenuator and connect the amplifier directly to the detector in and RF output. Then set your generator's output at a negative dBm value, approximately what you think the amplifier's gain might be, so that when you do your scan, the output of the amplifier won't be in excess of the +10 dB input limit on the RF detector input. Now remember to go in and set your y-axis minimum and maximum values, respective of a small RF amplifier that might have an output between +10 dBm and +30 dBm. We go ahead and do our cabling only scan, and we can see that the red line at the bottom of the display reflects our generator's output. Then we go ahead and store the value, hit relative, and our line pops up right to the 0 dB level. We go ahead and close the y-axis menu, and you can see under the x-axis the frequency range I was interested in. We go ahead and hit start, take the scan of our amplifier, And you can see with the cursor the values of dB gain at the exact frequencies along the plot. On a quick side note, know that the RF detector input does have some elbow room, so you're not going to blow it if you come up above the plus 10 dBm maximum input level for a few seconds. Next, we're going to perform a coaxial cable test. Because we're actually testing the loss of a cable over a given frequency range, we literally connect it from the RF output to the RF detector input. I'm going to test a hunk of unknown half-inch coaxial cable that's been in storage for a while. First, of course, we're going to scan the jumper cables we're going to use to hook up to the coax. When you're doing your scan of coax, of course you're going to set your frequency range in the area of frequencies you're intending to use the coax for. And also under the y-axis, I know that I'm not going to have more than 10 dB loss, so I set it to plus 10 to negative 10 for the entire range before the scan. Now, we're going to go ahead and also set the generator at 0 dBm. I'm going to go ahead and hit start and scan my cable assembly. Be sure you're in forward mode. And then, of course, store it and set it in reflected mode. Then we go ahead and attach our coax cable using the jumpers we've just scanned. We go ahead and do our scan of the coax. And, of course, we can use our mouse and cursor to move along and see the exact loss at any given frequency. As mentioned in the unit's main video, one of the great features now is the ability to store the scans of your basic cable assemblies. So you go ahead and do a scan, drop down the menu under plot here, and you can see that you can save the plot. And we're going to name it, 123, we'll put it in just for testing. Save it, and we can call it back up later when we're going to just swap out different bandpass filters or antennas. I'll load it back up, and that way you'll save time. The other thing is that we have an erase display feature, and that means if you're just going to keep the same reference plot and swap out bandpass filters or antennas, you can quickly erase the display and do another scan. The last thing we're going to talk about is immunity testing. All kinds of electronic devices are produced each year which must operate within the mixed fields of other radiating RF devices. These must be tested to see how they resist external RF fields. Although methodologies may vary, a test antenna is connected to the RF output, and the item under test is subject to RF fields at varying frequencies. On a final note, remember that under the System tab you can download the latest version of the software. It's constantly being updated, and you can look at your version history. Under the Link tab, you can see the firmware version, and you can upgrade from there. The TPI series generators are capable of a myriad of tests. We hope we've covered some of the most useful ones for you here. Please contact TPI with any questions or suggestions you may have. Thanks for watching.